Okay, one more example problem where we're looking at linear interpolation, right? So here we have a table. This is from the Social Security website. They have every single year, but we're going to just go by decades from 1960, just so that we can do some linear interpolation. Okay, this is National Average Wage Index by decade. And we want to use linear interpolation to determine what the corresponding national average wage index is at 1968, 2013, and 1996. So again, it doesn't matter what you choose for X or for Y. So I'm going to go through this quick since I already have a few videos doing the same process. So you identify, let's say for 1968, which two data points you're going to use. You're going to use 1960 at 4007 and 1970 at 6186. And you have those two data points and you're searching for the data point that's associated with 1968. So let's see, let me erase that. Okay. So we're searching, in this case, I put it in the denominator here. So I'm making my national average wage index my X parameter and the year my Y. And if you did it the opposite, that works perfectly fine. It really doesn't matter. And I find that this value is 5,750.42. Again, remember, you want to check to make sure that your solution is in between your two data points, because this is interpolation and not extrapolation. All right, so for 2013, you're going to use 2010 and 2020 and their corresponding wage index. And so that's what we did here. And again, we're searching for the wage index, and I put it in the denominator again, and I get 45,860.26, which is in between our original two data points. And finally, 1996. Let me use a different color. 1996 is I'm going to use 1990 and 2000 and their corresponding national average wage index. And there's my variable that I'm trying to find, or my parameter I'm trying to solve for. And I get 27,704.08, and that's in between these two values. So hopefully you'll get the point of linear interpolation. It's just matching the slopes using two known data points and one partially known data point that which you're trying to solve for the other component of. This gets used a lot, so understanding it conceptually and then having a way to quickly solve for it, either through some computer program or your calculator, you'll find it useful. This is used on tests and as you do projects or you calculate things from a financial perspective. There's a lot of uses, and basically it's a method to take discrete data and find values in between. Now, one thing to caution you before you apply this to a project or to some kind of analysis is be aware that you are making the assumption that between the two data points that you're identifying or that you're using from a known source, like in this case, this table, you are assuming that it has a linear relationship, right? So if you draw a straight line between these 2 points, that is the relationship or close to the relationship that the values in between those 2 points actually represent. And I think I talked about in an older video that this is not true when there's some kind of change, right? If you're looking at financial data and you have one data point well before the pandemic and one data point well after the pandemic, and you're trying to use it to interpolate some value within the pandemic or some kind of financial crisis, that's not going to be a good approximation because you're missing a lot of information. So typically you want those data points to be as close as you can get, but there's always things you have to a balance, right? It's like how much time you have to collect that data, or how much money it does it cost you to collect that data. So on a practical perspective, that's why we do interpolation instead of just collecting every single data set that we're looking for. All right, we'll do more linear equation example problems. The next step we'll look at is identifying an equation, y equals mx plus b, if you're given 2 data points. And again, that is also very useful when we're looking at values that you have and you're trying to find some kind of uh, uh, like correlation line. Then you could tell the code to use this equation instead of using specific data points.